So the traditional approach to applications on the left-hand side here had a focus on purpose machines, or better, reliable homogeneous data centers. The deployment and maintenance of applications tends to be manual, requiring administrative command line access to hosts, either bare metal or virtualized. If you were fortunate, you might have some automation through tools like Ansible or Chef or Puppet, but everything had to be just right. So it's not very resilient and it's very fragile. The anti-fragility movement focuses on cloud-native type apps that are resilient to failure and can be destroyed and repeatedly restarted through automation. Think of Netflix, Chaos Monkey, and later Simian Army. These illustrate an approach that likes to force random failures in order to test fragility and continue to make applications and infrastructure more resilient. And if you target the 4 metrics shown on the lower left, you will achieve DevOps success. Interestingly, targeting those metrics alone is sufficient to cause an entire cultural shift within your organization. So driving down the mean time to recovery, the change failure rate, and the lead time for change, and increasing your deployment frequency can have a dramatic effect on your organization. Security roles are different on either side. In the traditional model, it usually means being overworked, overstaffed, minimized, disliked, untrusted, and generally overwhelmed. Security professionals in the cloud-native world, it's more about being a mentor, a collaborator, accelerator, being respected, being a partner. How does this DevSecOps help improve the security? Well, we can't tell you that DevSecOps is easy, but we will tell you that each individual step can be. As long as you keep taking steps, you learn to walk and then to run. Start simple, implement a continuous integration system like Jenkins or automation using Ansible. Once that's done, add a stage to your continuous integration to do that code analysis for things like SonarQube. And those sort of steps take a few days each time. Once those 2 things are done, spread that knowledge to all the other teams and everyone is improved. Keep adding steps and stages as time permits, and this benefits the entire organization with each incremental step. And since we are automating these CI systems, this doesn't require daily work to continue using this. This frees up time to consider and mitigate new security threats, which you haven't been able to address before. Every journey is different, but almost all start with implementing one or more forms of automation. For development projects, that would be CI systems with an eye towards continuous delivery in the future. For network and other systems, it's using a configuration management tool like Ansible and writing roles, which are tested and validated. Tools which you integrate vary depending on your organizational needs and risk tolerance. I love this diagram. Imagine being responsible for the manufacturing process of this airplane manufacturer. Where do the parts come from? Is our supplier reliable and do they have integrity? Are they using the right materials to the rigorous standards that we require to make our aircraft? What about the employees? Do we train them well? Are we making sure that only trained personnel are allowed on the factory floor and that they're working at their designated stations? What about the tools? Are they allowed to bring their own tools? No. Are we maintaining their tools correctly, checking them regularly, servicing them, and updating them appropriately? Chances are the foreman, the person running this factory, trusts each part of this very complex system, this factory. So with modern DevOps and the accelerated CI/CD processes that come about as a result, your software factory is getting very complex like this with multiple products or projects running simultaneously. So what does such a factory look like for the DevOps world or the DevSecOps world? It looks like a CI/CD pipeline. You bake all the checks, validations, and compliance into the pipeline so that you know for sure when a project is deployed, it will meet the requirements. Add in all the tools you need to be successful: dependency checks, data code analysis, And as you go, you can even add stages to generate your evidence documentation for things like ATO, PCI DSS, HIPAA, GLBA, SOX, etc. Most organizations focus on the application pipeline, integrity of the libraries used, code scanning, etc. And there are many good examples of security practices that can improve the app development pipeline. But there are other areas to consider. The supply chain is also an area that people sometimes consider, but as we have seen time and time again, for example, with Docker Hub or certain JavaScripts being pulled down from repositories, we can never be too careful about ensuring the integrity of our suppliers and the artifacts that we bring into our organization. One way we can reduce risk is by scanning images and artifacts before persisting them in our repositories, and even then it's worth scanning them as we retrieve them for usage. The supporting infrastructure is also something that cannot be taken for granted. Consider configuration, playbooks, etc. as code. Use version control to maintain. Track the changes. Builds should be certified and signed. Errata should be updated regularly or immediately if required. This also extends to tools that you're using as part of your application development pipeline. They become part of your DevOps infrastructure. So who is installing them? Who has access? Who can make changes? Consider automating security around the installation and maintenance of these pipeline tools. All along, we need to be monitoring and logging so that we can be alerted to vulnerable situations and do proper forensics on the causes.